In stats, we went over expected value with binomial and geometric distributions and standard deviation. So these are the final formulas for this chapter, chapter 6. I don't know why, but I didn't type the standard deviation for geometric. So that would be this. And if you flip to your formula chart, all 4 of these are on your formula chart. So, by the way, that is right here. And notice, there they are. So you don't have to memorize these new formulas. And notice, these formulas are instead of using these 2 right here. Because you actually can use those 2 formulas in any probability distribution. Well, I should say any discrete probability distribution. But we're defining something as binomial, and this is a bit of a shortcut. Because instead of doing, let's change colors. Instead of doing this process here, all you have to do is do number of trials times p. Or 1 over p if you know it's geometric. So let's look at this word problem here and see if we can apply it. So this AP Stat class, they did this bottled water versus tap water study. And students were given 3 cups of water, 2 of them tap, 1 of them bottled. And they tell us there's 21 students. Probability of successfully guessing bottled is 1/3. X is the number of students who correctly identify the type of water. So I'd say it's let's see, BINS is our acronym. I'd say it's binary because students are right or wrong. For their guess. I stands for independent. And we're talking about 21 students each guessing. So a student's guess does not determine another student's guess. I guess in an ideal world, we're assuming they're all playing fair and no one is trying to help or whatever. N is fixed trials. There are 21 students. I don't think you need to say more than that. Probability of correctly getting bottled correct is 1/3. That is the same for all students because every kid has 1 out of 3 bottled in front of them. So it's binomial. Part B, it says find the mean and standard deviation and interpret. So the mean is very simple. It's n times p. In this problem, it's doable in our head. So we go 21 times 1/3, and we get a mean of 7. That means we expect seven students to correctly guess the type of water. On average. No, I don't even think we need to say that because we said expect. On average, we expect, yeah. So standard deviation. is 21 times 1/3 times 2/3. When we do that, we end up getting 2.1602. For that one, on average, the number of correct water guesses is 2.1602 within the mean. All right, so far not bad at all. Part C is an intro to hypothesis testing. Turns out 13 of the 21 made correct identifications. Does this give us convincing evidence that Mr. Bullard's students could tell the difference? So there's one thing, I think I've said it before, but in case I haven't, to determine if a value that occurred, and I'm talking past tense, is significant, find the probability of that value or anything more extreme. So that means 13 occurred. We expected 7, so this is higher than we expected. So that means we need to find the probability of X being bigger than or equal to 13. We already defined it as binomial. It's a greater than, so let's pull up binomial CDF. And we need to type some things into the questions it asks. We're starting at 13. It does have an upper bound of 21. And we're talking about 21 students and a 1/3 probability. When you do that, you get a very small probability of 0.0068. So let's make sure we answer the question. When we do this, we need context, we need to refer to the probability, and answer the question. So let's see, the probability of the class guessing correctly or type of water (13 or more times) is very small. And I would even emphasize less than 5%. Running out of room. It is very likely that the students can tell the difference. You can probably put a period right there. Between bottled and tap water. So it really did occur. The probability of guessing correctly that many times is rare. It should not happen, but yet it did happen. That implies they probably weren't guessing. They were skilled at determining bottled versus tap. All right, y'all have a great day. See you later. Bye.